Welcome back. This is your art math teacher, Sebisma. As we have been studying previously, differentiation. Today we are going to look at differentiation, which deals with trigonometry. So today we are going to learn how to differentiate trigonometry using the chain rule. Now, when we take a look at this example over here, which says that y equal to cos squared into bracket 2x plus 1. Now, from here, what do? We have to rewrite this trigonometry to suit the chain rule. So we are having y equal to cos into bracket 2x plus 1 all squared. Now, after you are done writing this, we have to now differentiate it. So we said that y will be equal to u squared. That's why over here. Now we differentiate dy over du will be equal to 2u. Now after you are done differentiating the u, you go back and substitute back into this function. So our dy over du will be equal to 2 cos into bracket 2x plus 1. After you substitute this into the function, we have to differentiate this again. So we are getting our y will be equal to cos of u. So our dy over du will be equal to, when you differentiate cos, we'll get minus sine u. Then our u will be equal to 2x plus 1. Now we'll differentiate this. So our du over dx will be equal to 2. Now after you are done differentiating, then you take this and multiply with this. So you will be heading to du over dx will be equal to negative 2 sine u. Then our u is giving us negative 2 sine, our u is what? 2x plus 1. Now after you are done over here, then you pick this and that. Then we multiply the two using the chain rule. So our dy over dx will be equal to 2 cos into bracket 2x plus 1 times negative 2 sine into bracket 2x plus 1. Then we multiply the 2. So our dy over dx will be equal to negative 4 cos into bracket 2x plus 1 sine 2x plus 1. So this is how differentiate trigonometry to the respect of the chain rule. So this is our final solution over here. Now we'll head to example 2 over here, which also says that y is equal to sine squared root of x. So as we have already studied from here, we have to rewrite the equation. So our y will be equal to sine, we have to rewrite it. So our sine will be sine into bracket root of x all squared. So we have to pick our y equal to our u. So our y will be equal to u squared. Now what do? We differentiate it. So our dy over du will be equal to 2u. Now after you are done, you just pick this and substitute this over there. So we have our dy over du will be equal to 2 sine into bracket root of x. Now when you are done, we have to differentiate what we have here. So our y will be equal to our y will be equal to sine u. So we differentiate this. So our dy over du will be equal to, when differentiate sine, we'll get cos. So cos what? U. Then our u will be equal to root of x. Then we can rewrite this to be u will be equal to x exponent half. Then we have to differentiate this. So we have du over dx will be equal to half x. Then when we subtract 1 from this, it will give us minus half. So we have to rewrite this. So our du over dx will be equal to 1 over 2 root of x. Then after you are done, we have to go and substitute it here. What we have just done here. So we'll be having 1 over u times this. So we have du over dx equal to cos u all over 2 root of x. Then we know our u to be root x, so we replace it. Du over dx equal to cos root of x all over 2 root of x. Now when you are done, you pick this and then we multiply with what we just did here. So our dy over dx will be equal to 2 sine root of x times cos root of x all over 2 root of x. So we can see something is happening here. We'll cancel this. So we now have dy over dx will be equal to sine root of x cos root of x all over root of x. So this is how we differentiate this trigonometry using the chain rule. So this is our final answer over here. So when we take a look at it very carefully, you can see that everything is moving accordingly. Now we will head towards to example 3. That will be our final example. So over here, as we already did from the previous example 1 and then example 2, we'll pick our y. We'll rewrite this to be y equal to sine into bracket 2x minus 1 or cube. So we have to pick the y equal to u exponent 3. Now we have to differentiate what we have over there. So y equal to 3u squared. Now after you are done differentiating this, we go back and substitute it back here. So our dy over du. So we substitute it back here. So we have dy over du will be equal to 3 sine, then our u is giving us 2x minus 1. But since there's a squared here, we put a 2 on the sign because we inverted it to be this. So now after we have gotten to this, we have to differentiate what we have here too. So our y will be equal to sine 2 sine square u. Then we have to differentiate it. So our dy over du will be equal to, when we differentiate sine, we'll get cos. So that will give us cos squared u. Now, what do we do next over here? We have to go and pick our u. So our u will be equal to 2x minus 1. So we have to differentiate this. So our du over the x is equal to 2. Now, what do we do next here? We have to multiply this by this. So our du over dx equal to 2 cos squared u. So now we know our u is giving us what? 2x minus 1. Now after we are done, we now multiply this by this. So our dy over dx equal to 2 cos squared into bracket 2x minus 1 times 3 sine squared into bracket 2x plus 1. So our final answer is going to be dy over dx equal to 6 cos squared into bracket 2x minus 1 sine squared 2x plus 1. Now, this is our final solution to this particular question. Now, so this is our solution on the board. So, from here, we are able to differentiate this trigonometry based to the chain rule, the same thing here. Thank you very much for following this lesson. I'm your Art Math teacher, Service Mark. Thank you very much.